Let's start with the most familiar one, the circle. A circle begins with a fixed point, which we call the center. Now, imagine a point moving in a plane, its distance from this fixed center always constant. This constant distance is known as the radius. The path traced by this moving point defines a circle. In mathematical terms, a circle is the locus of all points in a plane that are equidistant from a fixed point, the center. Next up, let's explore the parabola. A parabola is defined by a fixed point, the focus, and a fixed line, directrix. For a moving point P, its distance from the focus, PF, is always equal to its perpendicular distance from the directrix, PD. As P moves, the distance from P to the focus is the same as the perpendicular distance from P to the directrix. Therefore, a parabola is the locus of all points in a plane that are equidistant from a fixed point, the focus, and a fixed line, the directrix. Now, let's delve into the ellipse. Let's define an ellipse in terms of locus. An ellipse is defined by two fixed points called foci, F1 and F2. For an ellipse, the rule for our moving point P is that the sum of its distances from the two fixed foci always remains constant. Here, a constant sum of 6.0. Observe how PF1 and PF2 change, but their total sum never deviates from our constant value. So, an ellipse is the locus of points in a plane such that the sum of the distances to two fixed points, the foci, is constant. Finally, let's explore the hyperbola. A hyperbola is the locus of points where the absolute difference of its distances from two fixed points, the foci, is a constant value. Like the ellipse, a hyperbola is also defined by two fixed points F1 and F2, its foci. However, for a hyperbola, it's the absolute difference of the distances from the two fixed foci that remains constant. Here, 5. Notice how individual distances change, but their absolute difference holds steady. Thank you for watching.